All right, so we're going to compare some properties of quadratic functions in this example. So our example says the trajectory of water from fountain A is represented by a function in standard form. So here is the trajectory of the water in fountain A represented with this function, while the trajectory of water from fountain B is represented by a table of values. Compare the vertex of each function. What trajectory reaches a greater height in feet? All right, so one thing I want to point out, fountain A has a negative A value. That means that this parabola is opening down, and I think that kind of makes sense. If you think of the pathway of a water fountain, it's going to look like this. You know, it's coming out of the spout, goes up, comes back down. So it does model a parabola that's opening down. We have to identify the vertex of each function and then talk about the greatest height. So let's just do a little sketch of how a parabola that opens down might give us that information. So we know that this is the vertex of this parabola. Because it's opening down, that's the highest point. A vertex has an ordered pair, x, y. So how would you plot that point xy? From the origin, you'd go over x units, and you would go up y units to get to that vertex right there. So that's telling us that the height of whatever the parabola is modeling, the height is found by the y value of the vertex. Okay, so let's focus on fountain A first. To find the vertex, we want to recognize that we are in standard form. We're going to do the formula for the x coordinate of the vertex uses the negative b over 2a. So we have a negative, our b value is 2, the coefficient of x, over 2 times our a is a negative 1, the coefficient of x squared. That gives us negative 2 over negative 2, which simplifies to a positive 1. So in our vertex, we know, oh, that was a weird v. The x value is a positive 1. Now to get the y value, we are just going to plug in a 1 to our function. So our function has a negative and then the x squared. So we have to do a parenthesis, plug in a 1, and then square it. Take note of how this is written out for this first term. If you don't type it into your calculator like this, you will get a wrong answer. So be very careful. Plus 2 times 1 plus 8. We do that math and we get a positive 9. So the vertex of fountain A is 1, 9. What that tells us is we would go over 1 unit, up 9 units to get to the vertex of the parabola. So fountain A reaches a height of 9 units. All right, so how do we find a vertex when we just have a table of values? We don't have a function to do that negative b over 2a magic with, right? So let's see what we notice about these ordered pairs. We know that these functions are symmetrical. So if we look at the y values, do we notice any patterns where things are repeating and you might have reflection points? So what I notice is we have a y value of 5 and a y value of 5. The x values are different, you know, negative 6 up 5, negative 2 up 5. Those points are reflection points. So the vertex is somewhere in the middle of that. I notice we have another pair of points that have the same value, the same y value. These two ordered pairs have 8s, so those points are reflections of each other. And then this point right here in the middle, that one ends up being our vertex of fountain B. When the vertex is negative 4, 10, that means we would go from the origin to the left 4, but then you would go up 10. So fountain B has a height of 10. And then let's just go ahead and write in with fountain A that 9 was the height. Okay, so compare the vertex of each function. We did that. Here's the vertex of fountain A. Here's the vertex of fountain B. What trajectory reaches a greater height in feet? So which one got higher, fountain A or fountain B? Well, fountain B went all the way up to a 10, while fountain A only went up to 9 feet. So we can conclude the water from fountain B reaches a greater height. All right. One more question. Compare f of x equals this function in standard form to function g shown in the graph. So this is g of x over here. Maybe we'll label g of x. What are the maximum values? Which function has a greater maximum value? So maximum value is the highest point of the graph. If your parabola is opening down, the highest point is at the vertex, right there. So this vertex has the ordered pair 3, 0. And just like we saw in the last problem, it is the y value that gives us the height, or in this case, the maximum value. So for g of x, the maximum value is equal to 0. That's the highest that your graph gets. So if we can find the vertex of f of x, then we can find the maximum height and compare. So to find the vertex, we have to do our negative b over 2a because we are in standard form. So x equals negative, parentheses, our b is a negative 0.6. So there's that negative I talked about before, over 2 times a negative 0.3. So that negative 0.6 turns to a positive 0.6. 2 times negative 0.3 is a negative 0.6. And when you divide those, you get a negative 1. So we know that our vertex has an x value of negative 1. To find the y value, we'll just plug that in. So we have negative 0.3 parentheses, negative 1 squared, minus 0.6 parentheses, negative 1, minus 0.2. Type that in, and we get back a positive 0.1. So this 0.1 is the height, and because our parabola has a negative a value, that means it's opening down just like this one. So that is a maximum height versus a minimum. So that is a max height of 0.1. So which function has a greater maximum value? F of x has a greater maximum, oh gosh, can you even read that, value, let's say of 0.1. We'll just say what it is.